Hi everyone. In this class we are going to discuss about magnetic energy concept. In electrostatic, in capacitor, the energy stored in electrostatic field is W suffix E is equal to of L of CV square. And in magnetostatic, in inductor, the energy stored in magnetostatic field is given by W suffix M is equal to of Li square. Consider a differential volume. Consider a differential volume in magnetic field V bar shown in figure. Now here the magnetic flux density is flowing in y direction. Consider that at the top and bottom surfaces of the differential volume and the conducting sheets with currents delta I are present. In this figure, the magnetic field intensity is flowing in y direction, and this is the top and bottom surfaces, and the top and bottom surfaces differential volume and the currents are delta V and delta I. Delta I and delta V is the differential currents and differential volumes. From the definition of an inductance, we can write the inductance of a differential volume is delta L is equal delta pi by delta I, where delta pi is equal the magnetic flux is the magnetic flux density into differential surface area, that is delta pi is equal B into delta S, where the flux passing through the surface area is given by P is equal surface integral of V bar dot ds bar. Differentiating that equation, we get delta pi is equal B into delta S. The flux passing, the magnetic flux density is passing through normal to the surface, and differential surface area ds bar is also passing normal to the surface. We get the dot product of the same unit vectors is unity. We get the magnetic flux delta pi is equal B into delta S, where delta S is the differential surface area. Now here the magnetic flux density is passing to the y direction, so therefore the differential vector surface area delta S is delta x into delta z, and substitute delta S value in the above equation, we get delta L is equal B into delta S by delta I is equal B into delta S is delta x into delta z divided by delta I. But we know that B is equal to mu into h, and substitute B is equal to mu into h into the above equation. Therefore, delta L is equal mu h into delta x into delta z divided by delta L. Delta I. Now, the differential current dI can be represented in terms of magnetic field intensity H bar. The current flowing through the conducting sheet present at the top and bottom surfaces in the y direction is delta I is equal to H into delta Y. The energy stored in the inductance of a differential volume is given by delta Wm is equal of delta I into delta I square. And substitute delta L value and delta I values into in this equation, and this is the delta I value and this is the value of delta L, and substitute delta I and delta I into in this equation, we get energy stored delta Wm is equal 1 by 2 into mu h delta x delta z by delta I into delta I square. Numerator and denominator 1 delta I is cancelled, we get delta Wm is equal of mu h into delta x into delta z, and substitute delta I value h into delta y, that is equal of mu h into h square delta x into delta z into delta y, so that is equal of mu h square into delta v, where delta v is the differential volume, where the differential volume delta v is equal delta x into delta y into delta z. The magnetic energy density function is defined as Wm is equal limit delta V tends to 0 delta Wm by delta V, that is equal of mu h square. So that is the magnetic energy density function. definition. An energy density function is represented in joules per meter cube. The magnetic energy density function can be represented in differential forms, various forms. So this is a one form, Wm is equal to half into mu which is square. In another form of the magnetic energy. So what are the another form of the magnetic energy? Wm is equal to half into mu h square. H is written as h into h. Mu h is Bh. 1 by 2 into Bh is the another form of the magnetic energy. And another form of the magnetic energy is Wm is equal to B square by mu h. B square by mu h. In linear medium, the energy in a magnetostatic field is given by Wm is equal to half into Wm into dV. But the magnetic energy density Wm is equal to B bar dot H bar, and B bar dot H bar value is mu into H square, half mu into H square, and one more relation of the half mu H square is 1 by 2 into B square mu. So this is the energy in magnetostatic field in linear medium. Different relations, different expressions. Next concept is energy stored in magnetic field. Energy stored in magnetic field. Energy stored in electrostatic field of a capacitor. Energy stored in magnetostatic field of a inductor. Capacitor is the energy storage element in electrostatic. Inductor is the energy storage element in magnetostatics. We know that the induced EMF E is equal to L into di by dt, and the induced EMF and also the induced EMF E is equal to N into d pi by dt. The differential work done in time dt and dw is, we have dw is equal to Vi into dt joules, where V is the L into di by dt into I into dt. Numerator and denominator dt is the cancel, we get Li into di. The total work done Wm is equal, integrating the above equation on both sides, we get total work done Wm is equal integral dw, that is equal integral 0 to I Li into di. L is the constant that is written before integration. Integral I di is I square by 2. After applying upper value and lower value of I, we get of Li square joules. So this is the total work done in magnetostatics, where W suffix m is the energy stored in magnetostatic field. And see the animation. See the animation. Inductance L is equal to N pi by I, that is equal to lambda by I. N pi is the total flux linkage of the coil, and the magnetic energy stored in magnetostatic field is of Li square, and the different relations of lambda I. Next concept is energy density. The energy stored in magnetic field of the inductor is given by of Li square, and the inductance of a solenoid is given by L is equal mu n square A by L, and substitute L value into above expression, we get Wm is equal 1 by 2 into mu Ni by L, we get final equation Wm is equal of mu H square into volume. Substitute this L value into this equation. After substituting, reducing the expression, we get the energy stored in magnetic field is Wm is equal of mu h square into volume. Therefore, the magnetic energy density for volume is given by Wm is equal of mu h square joules per meter cube. But B is equal to mu into h, and one more expression of the magnetic energy density is of 1 by 2 into Vh.